Alright, let's take a look at another way to multiply vectors. We saw the dot product. The dot product, if you remember, gives us back a scalar answer, or scalar quantity. The cross product, however, is going to give us back a vector. And we would say if we had some vector A and some vector B, that the cross product gives us a vector perpendicular to both of those. So this is A crossed into B. And the length of that vector is equal to the area inside this parallelogram, if we were to draw it. Alright, so that area is equal to the magnitude of A crossed B. I'll show you how to calculate the vector quantity, but if they just wanted to know the magnitude of A cross B, we could also say that is just A times B times the sine of the angle between them. I wouldn't count on using that too much, but it's good to note that if you remember the dot product had a cosine right here. The dot product maximized when the two vectors were parallel to each other. The cross product has a sine, so it's going to maximize when the sine of 90 exists, so that equals 1. So you actually get the full A times B contribution. If the angle between the vectors is 0 or parallel, the cross product will be equal to 0. Okay, so that's what the cross product is. I thought that was important before we just keep putting down formulas. One way that you should consider being able to visualize it is if you take your pointer finger and put it in the direction of A, and take your middle finger and put it in the direction of B, and then extend your thumb up all the way as high as you can. Whatever direction your thumb is facing is going to be the direction of A crossed B. It's obviously not going to represent the length, but it gives you a sense. So like if you're thinking about, and I'll do an example or talk about torque. Torque is equal to R crossed into F. The distance from the point of rotation crossed, or the position vector from the distance of rotation crossed into the force that's applied, and force is also a vector. So it'll give you the rotation axes at least. So it always helps to visualize it. So let's say we're given two vectors, A and B. Each vector has an x component, a y component, and a z component. If I wanted to take the cross product of the two, or A crossed B, the definition comes from actually putting these in a determinant where this is I, J, and K. This would be our A sub x, our A sub y, and our A sub z. And then the same for the B vector. X component, y component, z component. And we take the determinant of that thing. The way I was taught is to take the first determinant portion, you cross these two out, you're going to get something multiplied by this now, because we get a vector as our answer. So we just make sure, right? The dot product gives you a scalar. The cross product gives you back a vector. And then what we do is take the determinant of this thing. So the determinant of that would be these two multiplied together. AY times BZ minus these two things multiplied together. AZ times BY. Okay, and then we would do the next, the same way, I would put my line through here. We would get our j values by taking the determinant of those ones now. And then we would take the determinant for the k values of these ones. That's probably the best way to practice. You really are going to be working with matrices a lot, not in this class per se, but definitely in your future. Like any of your degrees that I can think of, you're going to be putting data into matrices and then operating on them. But a lot of people actually just memorize this formula too. If I continued doing the determinant, I would get AZ times BX minus BZ times AX, and that would be in the J direction. Put a plus sign. And for the K direction, we would get an AX, a BY, and then subtract a BX and an AY. So there you go. That's you can actually put that on a note card in some cases. Your calculator will actually do a cross product, but I really recommend being able to do it with the determinant. That's a definition, and you want to take a qualifying exam to get into grad school for physics or engineering. You're going to need to know how to take the determinant of a 3x3 matrix. Like it's a thing. So don't just take the cheat sheet formula out, or the cheat sheet method out. Let's talk about an example of this, because I know like dot product and cross product are not easy to comprehend without some sort of example. But let's say this is some mass, some blob, who knows, but it's got some axis of rotation like this. Some force could be getting applied, and you don't need to know how to do this just yet. I'm just using force and the position vector to get torque. We will work on this in the future, but we have some force vector, and if I wanted to draw that position vector where the force is being applied, it would be something like this. We can call that R. Now we'll find in the future that a thing called torque, which I know you've experienced before, is equal to R crossed into F. We get back a vector, and in this case it's basically if we made a perpendicular from these two vectors, how much of that force is perpendicular to this arm right there, and that will cause what's called a moment or a torque around this axis of rotation. And if forces are analogous to accelerations, we'll find out that torques or moments are analogous to angular accelerations or alpha. So that's my example of when you would use the cross product, and there's plenty more, but I know that you guys already know about torque. Okay, let's take a look at what happens if we take the cross product at different angles, because the cross product, we can say it maximizes at perpendicularness, or 90 degrees perpendicularness, and it'll minimize or go away at 0 degrees, or if it's parallel. So by definition, we said the magnitude of A cross B is equal to AB sine theta. So think about as sine of theta, a sine goes to 90 degrees. This turns into 1, and we get a full effectiveness of A times B. So A times B times 1. Now if the angle is 0 degrees, the sine of 0 is 0, and we get nothing. We get 0 back. So if a vector is at a completely right angle to the other vector you're crossing it into, you will get A times B back. If a vector, and that's the area of a square, right? You should get A times B back if the cross product is equal to that area. If they are parallel, say this is A and B, then the angle between them is 0 by definition, and the cross product ends at 0. So A crossed B for this one is equal to 0. Couple quick notes. What I just said we can put in a word form. I can say I crossed into I is equal to 0. If it's in the same direction and I cross them, I get 0 back. I can also say J crossed into J is 0, and K crossed into K is 0. Now as for the other ones, I use a little trick. I say, okay, I draw this on my paper if I take a test or something too. I say, here's I, J, and K. If I had to cross I into J will give me a positive K back. If I cross J into K, I get a positive I. If I cross K into I get a positive J. And I can go backwards. If I cross I into K, sorry, I want a different color. If I crossed I into K, I get negative J. If I cross K into J, I get negative I. And J into I, guess what? I get a negative K. So we can say A crossed into B is equal to negative B crossed into A. Alright, I think that sums it up. We'll do some examples too.